Configure router on a stick, Inter-VLAN routing. Topology. On packet tracer, router 4321, R1, switches 2960 switches, S1 and S2, 2 PCs, PCA and PCB. Gigabit 001 on router to fast Ethernet 5 on S1. Between switches, fast Ethernet 1 on both sides. Switch 1, fast Ethernet 6 to PCA. And switch 2, fast Ethernet 18 to PCB. Addressing table. R1 subinterfaces, subinterface 1.3, 1.4, 1.8, S1 management interfaces on VLAN 3, and PCA and PCB configuration. The VLAN table, VLANs 3, 4, 7, and 8. Build the network, cable the network, already done. Configure basic settings for the router. These configurations were made in another labs for security and for basic settings. So this for me is optional, and I will only assign a device name to the router. Configure basic settings for each switch. Okay, these configurations were made in another labs, and for me it's optional. I will only configure the device name on the switches. Configure PC hosts. Addressing table. Okay, PCA and PCB. PCA 192.168.3.3 subnet mask 24 192.168.3.1 is the default gateway, and PCB 192.168.4.3 subnet mask 24 default gateway 192.168.4.1. Create VLANs and assign switch ports. You will create VLANs as specified in the table above on both switches. You will then assign the VLANs to the appropriate interface. Create VLANs on both switches. Create and name the required VLANs on each switch from the table above. Okay, go to the table, VLAN table, S1, command line interface, enter, enable configure terminal. Don't forget the host name, S1, enter, VLAN 3, name management, VLAN 4, name operations, VLAN 7, enter, name parking lot, no spaces, case sensitive, VLAN 8, sorry, VLAN space 8 name native. Enter. Okay, exit. Okay, S2, S2. Command line interface, enter, enable, configure terminal, hostname S2, VLAN 3, name management, VLAN 4, name operations, VLAN 7, name parking lot, VLAN 8, name native. Exit. Configure the management interface and default gateway on each switch using the IP address information in the addressing table. Okay, for S1, this configuration, IP address and default gateway. VLAN 3, okay, S1, click on S1, okay, S1, verify and interface VLAN 3, enter IP address 192.168.3.11, subnet mask 24. Enter, no shutdown, exit, and IP default gateway 192.168.3.1. Enter. Go to S2, interface VLAN 3, enter IP address 192.168. Okay, on VLAN 3, IP address 3.12. 3.12, subnet mask 24. Okay, now shut down. Exit, IP default gateway 192.168.3.1. And okay, notice that the default gateway was configured on global configuration mode, and IP address and subnet mask are configured on interface configuration mode. Assign all ingested ports on both switches to the parking lot VLAN. Configure them for static access mode and administratively deactivate them. Okay, start from S1. Okay, interface range and select all the unused ports. Okay, on S1, 5 in use, 1 in use, and 6 in use. Okay, if 1 is in use, fast Ethernet 2 to 4, comma, fast Ethernet 5 and 6 in use, 7 to 24, and gigabit 01 and 02. Okay, this is the range for all unused ports on S1. Enter. Static access mode. Switch port mode access. Parking lot VLAN. Okay, parking lot VLAN is VLAN 7. Okay, parking lot VLAN, VLAN 7. Switch port access VLAN space VLAN 7. Exit. Go to S2. Fast Ethernet 1 in use and Fast Ethernet 18 in use. Okay, interface range, Fast Ethernet 2 to 17 and 19 to 24 and gigabit 01 and 02, all unused ports. Switch port mode access, switch port access, space VLAN 7, exit. The interface range command is helpful to accomplish this task with as few commands as necessary. Assign VLANs to the correct switch interfaces. Assign used ports to the appropriate VLAN, specified in the VLAN table above, and configure them for static access mode. Okay, go to S1, click. Fast Ethernet 1 will be a trunk interface. Also, Fast Ethernet 5 will be a trunk interface. You need to configure only Fast Ethernet 6 for access modes because it's connected to an end device. Okay, interface Fast Ethernet 6, switch port mode access. Okay, static access mode, and use the appropriate VLAN. Okay, go to the table. Fast Ethernet 6 on S1 belongs to VLAN 3. Fast Ethernet 6 on S1 belongs to VLAN 3. Okay. Switch port access, space VLAN 3. Enter. Okay. Exit. Okay. Fast Ethernet 6 on switch S1 belongs to VLAN 3. Very good. Click here. Okay, S1 and S2 VLAN 3 already configured. Okay, S1 on S1 VLAN 3 already configured with an IP address, and on S2 VLAN 3 already configured. Go to S2. Okay, interface VLAN 3 configured with IP address. Okay, already done. Now on S2 Fast Ethernet 18 on VLAN 4. Okay, S2 Fast Ethernet 18 on VLAN 4. S2 interface Fast Ethernet 18, switch port mode access, and access VLAN 4. VLAN 4. Enter. Exit. Okay, S2 Fast Ethernet 18 VLAN 4. This end device, place it on VLAN 4. Very good. All unused ports on VLAN 7 already done. Very good. And native VLAN will be configured for the trunk interfaces. Show VLAN brief to verify. S1 and show VLAN brief. Okay, 1 and 5 to default VLAN, 6 to VLAN 3, and all unused ports VLAN 7. Go to S2. And show VLAN brief Fast Ethernet 1 by default on VLAN 1, Fast Ethernet 18 on VLAN 4, all unused ports on VLAN 7. Configure an AO2.1Q trunk between the switches. Manually configure interface Fast Ethernet 1 is trunk. Okay, this is the trunk connection on Fast Ethernet 1 on both switches. Manually configure trunk interface Fast Ethernet 1. Change the switchboard mode on interface Fast Ethernet 1 to force trunking on both switches. Okay, Fast Ethernet 1 on S1. Configure terminal interface Fast Ethernet 1 switchboard mode trunk. Enter. And on S2, Fast Ethernet 1. Enter. Configure terminal interface Fast Ethernet 1 switchboard mode trunk. Enter. Okay. Very good. As a part of the trunk operation, set the native VLAN to 8 on both switches. Okay, go to S1. Okay, on interface configuration mode, interface Fast Ethernet 1, switchboard, trunk, native VLAN 8. Enter. Go to S2. Enter. On interface configuration mode, on interface Fast Ethernet 1, on interface Fast Ethernet 1. Okay, enter. Switchboard, trunk, native VLAN 8. Enter. Okay. You may see error messages temporarily while the two interfaces are configured for different native VLANs. Okay, you will see inconsistent peer VLAN ID. Okay, when the inconsistent local VLAN, when the native VLAN on switches are different, but after configure the same VLAN, the same native VLAN on both switches, native VLAN 8, port consistency restored. Consistency restored. Enter. Very good. And as another part of trunk configuration, specify that VLANs 3, 4, and 8 are only allowed to cross the trunk. Okay, go to S1 on interface configuration mode on interface Fast Ethernet 1, switchboard trunk, allowed VLAN 3, 4, and 8. 3, 4, and 8. Enter. And go to S2 and interface configuration mode on interface Fast Ethernet 1, switchboard trunk, allowed VLAN 3, 4, and 8. Enter. Show interfaces trunk to verify. Go to S1 and show interfaces trunk. Okay, Fast Ethernet 1 static trunk on encapsulation AO2.1Q. Trunking port native VLAN 8. Allowed VLANs 3, 4, and 8. Go to S2 and show VLAN brief. Okay, Fast Ethernet 1 is a trunk port and is not placed on show VLAN brief output. It's not placed on VLAN table. Okay, no Fast Ethernet 1 here because it's a trunk interface. Okay, show interfaces trunk. Here is facet 1 static trunking on encapsulation trunking port VLAN 8, VLANs allowed 3, 4, and 8. Manually configure S1 trunk interface facet 5. Now, to connect the router, to connect the sub-interfaces on the router, facet 5 on S1 should be trunk. Configure facet 5 on S1 with the same trunk parameters as facet 1. This is the trunk to the router. Okay, go to S1, configure terminal interface facet 5, switch port mode trunk for static trunk, switch port trunk, switch port trunk, native VLAN 8, enter. And switch port trunk allowed VLAN 3, 4, and 8. Very good, exit. Show interfaces trunk to verify. Okay, and show interfaces trunk. Okay. Only facet 1 is trunk. Why? Because facet 5 is not an active port, because R1 interface is shut down. So this link is down. Okay. Why does facet 5 not appear in the list of trunks? S1 port 5 will not be displayed because the Gigabit Ethernet 001 interface status on the router is administratively down. Configure Inter-VLAN routing on the router. Activate interface Gigabit 001 on the router. Okay, go to R1. Command line interface, no. Enable configure terminal. Hostname R1, enter. Activate interface Gigabit 001 on the router. This interface connected to S1. But I recommend to do this at the end. I recommend that. Now, configure sub-interfaces for each VLAN as specified in the IP addressing table. All sub-interfaces use AO2.1q encapsulation. Ensure the sub-interface for the native VLAN does not have an IP address assigned. Include a description for each sub-interface. Okay, go to addressing table and configure all sub-interfaces for this router R1. Interface Gigabit 00001.3. Enter. Configure the encapsulation. Okay, encapsulation .1q belongs to VLAN 3. Okay, VLAN 3. Enter. Set the IP address. IP address 192.168.3.1. Subnet mask 24. Enter. And don't forget the description. The description can be the name of the VLAN, for example, VLAN management or VLAN 3. Okay, you can, any description management. Okay, enter. Now, the next sub interface 1.4. 1.4, encapsulation .1q4, IP address 4.1, subnet mask 24. Description can be the name of the VLAN. VLAN 4 is operations VLAN. You can say operations. And finally, the last sub interface, gigabit 1.8. 1.8, enter. 1.8 does not have IP address. Only configure the encapsulation .1q.8 space native. Okay, because 8 is the native VLAN. Okay, VLAN 8, native VLAN. So you need to add this keyword, native. Enter. And description, native, or any description. And now enable the physical interface. Gigabit 001, no shutdown. Enter. Very good. All sub interfaces up. Now this indicator is green. Show IP interface brief to verify R1 and show IP interface brief. Enter. And you can see gigabit 001 up the physical interface with no IP address, status up, protocol up, sub interfaces up, status up, protocol up. Very good. Verify inter-VLAN routing is working. Complete the following tests. Okay, on real Windows PCs, you may have to disable the PC firewall for pings to be successful. Ping from PCA to its default gateway. Okay, go to PCA, command prompt, ipconfig, and this is the default gateway for PCA 3.1, ping 192.168.3.1, enter. Success. From PCA ping PCB. Verify the IP address of PCB is 4.3. Go to PCA, ping to 4.3, enter. Success. Ping from PCA to S2. Okay, S2 IP address 3.12. Go to PCA 3.12, enter. Okay, very good. And also you can ping S1, that is 3.11. Success. Complete the following test from PCB. From the command prompt on PCB, issue tracer command to the address of PCA. Okay, go to PCB, command prompt, tracer to PCA. PCA IP address is 3.3. 192.168.3.3, enter. Okay, two hubs. One hub is the router, and the second hub is PCA. Why? Because PCB is placed on a different VLAN of PCA. And R1 is necessary to communicate between different VLANs. And PCB goes first to R1 and then goes to PCA. First to R1 and finally to PCA. What intermediate IP addresses are shown in the result? Okay, the tracer output shows two entries in the results. The first hop is gigabit 001.4 on the R1 interface address, which is the gateway address for PCB. The second hop is PCA address. Okay, ipconfig on PCB, and 4.1 is the default gateway of PCB, and this is the first hop, so that's why it's R1. And finally, 3.3 is the IP address of PCA. Very good. Thank you very much.